the shortest distance between these two points we kind of learn in school is just a straight line here. So if you drew the map and you said, okay, what's the shortest path between here? You'd think, okay, I'm just going to draw a straight line, and that's the path that I'm going to take. Now, of course, if you're on a cruise ship, you're very incentivized to take the shortest path between those 2 points because, we use a lot of fuel, takes a lot of money, costs a lot of time, and we don't want to waste anything. We want to be as efficient as possible. Is that the shortest path between these 2 points, when you plot it on a map, actually looks more like this. It looks more like a curve. So here we go. This is what that looks like. So the take-home message here is that if we have the shortest path between 2 points on a curved surface and we project it onto a flat surface, it ends up looking distorted. So if we put this map back onto a sphere, kind of where it belongs, it becomes a bit easier to see this, okay? So this solid line, that's the great circle path, which is the shortest distance. And then this dashed line, that's what looks like a straight line if you plot it on a map. But you can see here on a sphere that it's actually not the most direct path. So what does this have to do with cosmology and outer space? Well, one of the big realizations of Albert Einstein was that space itself can actually be curved in a similar way to how the surface of the Earth is curved. It's not exact, but you can kind of think of that as an analogy. And the space can get curved by the presence of matter. So if you have a lot of matter, you can end up curving space. And photons, in kind of the same way that a cruise ship has to take the shortest path between 2 points, photons also always try and take the shortest path between 2 points. But in curved space, that shortest path can end up looking distorted. So we can kind of see what's going on here. If we have a galaxy over here, and a big clump of invisible matter, that invisible matter is actually distorting the space around it. And as these photons travel towards us, they're actually taking the shortest path, even though here it looks like they're taking a less direct path. This is the shortest path in that curved space. So when we project it like this, it ends up looking distorted. And we call this gravitational lensing. In a way, it works very similar to lensing just by regular pieces of glass, regular optics. So if you wear glasses, it kind of works in that same way. But it's caused by the curving of space itself. And we first had telescopes which were able to kind of image this, and I guess roughly the sort of 80s. And I can show you a picture of what these gravitational lenses look like. Has anybody seen a picture like this before? Yeah, so a few people. So what we have going on here is a big cluster of some kind of invisible matter here. And you can see at the edges here, we have these arcs, these distorted arcs here. These are actually images of galaxies which are sitting behind the cluster. And as their light has traveled towards us, that shape has got really distorted by the cluster. So if we look at this image here, we can kind of see just by eye that it looks like there must be a really big cluster of matter here, which is distorting those background images. So this is one of the ways that we can tell there must be some invisible matter sitting there that we can't see directly.